Good evening, students. In the last class, we discussed problems in existence of the limit. Okay. In this class, we are going to discuss rules to find limit. In that, we will discuss algebra of limits and sandwich rule. Okay. So let's start our lecture. This is our lecture number 3. Okay. Lecture number 3. Okay. First one. Rules to find limit. Okay. In this, we will discuss algebra of limits. Okay. Okay. Good. Let's consider two functions f of x comma g of x. ठीक है, such that limit x tends to a f of x equals to l. ठीक है, when x tends to a f of x equals to l. Okay, and limit x tends to a g of x equals to m. Okay, and l comma m adjust. So let's consider two functions f of x and g of x. Okay, and limit x tends to a f of x equals to l. Okay, and limit x tends to a, same a. Okay, here also a, here also a. F of g of x equals to m. Okay, and let l comma m adjust. What does it mean adjust here? Let me explain what does it mean adjust here. Okay, adjust here in the sense ki limit x tends to a adjust. Okay, l adjust, इसका अर्थ ये है कि limit x tends to a minus f of x equals to limit x tends to a plus f of x. Okay, limit adjust, l adjust means limit adjust. Okay, it means limit h tends to 0 f of a minus h equals to limit h tends to 0 f of a plus h. Okay, good. So this is what adjust here means. Similarly m adjust means limit x tends to a minus f of x g of x. Okay, because we are taking m correspond to g of x. Okay, equals to limit x tends to a plus g of x. ठीक है, this is equals to again limit h tends to 0 g of a minus h equals to limit h tends to 0 g of a plus h. Okay, understand? L adjust means limit h, so limit h tends to 0 f of a minus h equals to limit h tends to 0 f of a plus h. M adjust means limit h tends to 0 g of a minus h equals to limit h tends to 0 g of a plus h. If these L and M adjust, then we will have the following rules. Okay, okay. What are the rules? Chalo, let's start. Okay. Let's erase this one. First rule. The first one is limit x tends to f plus or minus g of x equals to limit x tends to a, ठीक है, f of x plus or minus limit x tends to a g of x. Okay, so let's explain through example. Let f of x equals to x square, g of x equals to 2x, then find limit x tends to 1 f of x plus g of x. This is the question. Okay, f of x equals to x square, g of x equals to 2x, then we should find limit x tends to 1 f of x plus g of x. Okay, good. So let's see, we have condition. What is the condition? The condition is, for using this formula, from using this rule, okay, both, and this is equals to L plus m. Okay, for using this rule, both limit x tends to a f of x and limit x tends to a g of x must exist. Okay, these two must exist for using this rule. If not, you can't use this rule. I will show why we can't use rules. Okay, so condition is both limits must exist. L comma m must exist, then only you can use this. Okay, so let's see whether they're existing or not. Okay, limit x tends to 1 x square equals to, let's find left hand limit. Left hand limit equals to limit x tends to 1 minus x square equals to limit h tends to 0 1 minus h whole square. ठीक है, because limit x tends to 1 minus f of x equals to limit h tends to 0 f of 1 minus x 1 minus h. In place of x we have 1 minus h. Okay, so here it is just h tends to 0, it is 1 square equals to 1. Okay, similarly right hand limit, limit x tends to 1 plus x square equals to limit h tends to 0 1 plus h whole square equals to 1 plus h square plus 2h. Since h is tending to 0, this tends to 0, this tends to 0, and this tends to 0, and it is equals to 1. Okay, good. Left hand limit of x square we got 1, and right hand limit of x square we got is 1. Okay, since left hand limit equals to right hand limit, implies limit exist. Okay, and the limiting value is limit x tends to 1 x square equals to, what is the limiting value? 1. Means here we got L equals to limiting value equals to 1. Okay, means L equals to 1. Okay, remember. Okay, good. So similarly we can do for 2x. Limit x tends to 1 g of x equals to limit x tends to 1 2x, and let's find left hand limit. Left hand limit is limit x tends to 1 minus g of x 2x equals to limit h tends to 0 2 of 1 minus h. Okay, good. So it is 2 minus 2h, limit h tends to 0, it is tending to 0, so it is tending to 2. So left hand limit we got is 2. Okay, similarly if you find right hand limit, ठीक है, understand, limit x tends to 1 plus f of x is 2x, so equals to limit h tends to 0, 2 into 1 plus h equals to 2. Limit h tends to 0, this tends to 0. Okay, so here again left hand limit equals to right hand limit equals to 2, means we can say, what we can say, and left hand limit equals to right hand limit equals to 2, what we can say, limit x tends to 1 g of x means 2x adjust. Okay, and so we can say limit x tends to 1 g of x adjust, and value of that is m equals to 2. Good. So our condition, what is the condition? For using these rules, both L and M should adjust. Okay, so here L adjusted, we got L equals to 1, and M adjust, we got M equals to 2. So we can use this formula right now. So directly, our students, I am taking small examples because to make you understand very clearly. Okay, in coming classes we will do tougher problems with these concepts. Okay, so the question is limit x tends to 1 f of x plus g of x. Okay, so equals to limit x tends to 1 f of x plus g of x is x square plus 2x. Okay, and equals to, and what is this? This is equals to, since our condition both this and this adjust, so we can place here limit x tends to a f of x plus limit x tends to a g of x equals to L plus m. Okay, and what we got, L we got L equals to 1 plus m we got 2, so answer is 3. Okay, समझ में आ रहा है? चलो, here the question comes, question, I want to frame one question here. Okay, can we use the rule, the same rule? Okay, to find left hand limit x tends to a f of f plus g of x, if either of, okay, either of L comma M don't adjust, does not adjust. Okay, so my question is, can we use the same rule to find limit x tends to f plus g of x if either of L comma M don't adjust? Can we use this? The answer is no. Okay, why? I will explain reason by taking one example. Okay, let's take example. Okay, f of x equals to step x, ठीक है, and g of x equals to floor of x, fractional part of x. Okay, so now the question is, I want to find limit x tends to 1 f of x plus g of x. This is the question. ठीक है, they given f of x equals to step x, g of x equals to flower plot of x, and we should find limit x tends to 1 step f of x plus g of x. Okay, so let's see whether these individual functions step x and flower part of x will they satisfy the condition of existence of limits. Okay, see, consider f of x equals to step x. Okay, good. Now let's see whether limit x tends to 1 f of x exists or not. Taking left hand limit, okay, left hand limit we can use limit x tends to 1 minus, okay, f of x equals to limit h tends to 0 f of 1 minus h. ठीक है, so it is equals to limit h tends to 0. Since f of x is step x, f of 1 minus x h is step of 1 minus h. ठीक है, good, understand now. So limit h tends to 0 step of 1 minus h is, since h is positive and infinitely small, 1 minus h is less than 1. Okay, good. So it is less than 1, so step of quantity which is less than 1, so it is 0. Left hand limit we got 0. Okay, similarly we can find right hand limit. Right hand limit is limit x tends to, okay, x tends to 1 plus f of x equals to limit h tends to 0 f of 1 plus h. ठीक है, so limit h tends to 0 f of 1 plus h equals to, substitute step x here, limit h tends to 0 step of 1 plus h. Okay, since h is positive and infinitely small, this term step of 1 plus h is greater than 1. Okay, so h is positive, so 1 plus h is greater than 1, and step of 1 plus h is, no, because 1 plus h is between 1 and 2, so step of 1 plus h is must be equals to 1. Okay, it is integer number which is between 1 and 2. So what we can see from here, left hand limit is not equals to right hand limit. ठीक है, so limit does not adjust. ठीक है, good. So limit does not adjust. Let's write right here, left hand limit equals to 0, right hand limit equals to 1. ठीक है, now let's find g of x. G of x equals to flower part of x. ठीक है, so limit x tends to, so let's see whether this flower part of x exists or not at x equal 1. Okay, so limit x tends to 1 g of x equals to, let's find left hand limit. Left hand limit equals to limit x tends to 1 minus g of x. G of x is flower part of x equals to limit h tends to 0 flower part of 1 minus h. Good. Students, you know flower part, we know that flower part varies from between 0 and 1. Okay, so it is always positive. Flower part is always positive and it varies from between 0 and 1. So since h is positive here, okay, h is positive, so 1 minus h is less than 1 and 1 minus h is greater than 0. Why? Because h is very small, so 1 minus h is less than 1 and 1 is greater than 0. Okay, so flower part of 1 minus h must be equals to 1 minus h only. Okay, because here integral step x is 0. Okay, so we can write as this is equals to 1 minus h only. Okay, so good. The maximum, if h tends to 0, the maximum value of this, if I observe, it can be equals to 0.9 bar. Okay, because h, the smallest value of h, if you take, if it is just greater than 0, the smallest value of h is, we can take it as 0.000001. Okay, so then 1 minus h value, the maximum value of this can be 0.9 bar, 0.99999 up to. Similarly, right hand limit equals to limit x tends to 1 plus, okay, good, flower of x equals to limit h tends to 0. Okay, flower of 1 plus h. Okay, and flower of 1 plus h is, this is h. Okay, and this value is you can say 0.001. Okay, that is the least possible value h will have, and 1 minus h will have maximum value 0.9 bar. Okay, now if you observe, left hand limit not equals to right hand limit implies limit does not exist, so okay, now limit left hand limit is 0.91, right hand limit is 0.00. Okay, now let's find the question. Then let's go to question. The question is limit x tends to 1 f of x plus g of x. Okay, so it is limit x tends to 1 step x plus flower part of x. Okay, so let's find okay, before going to question. Okay, here I said we can't use the formula, this rule, because limit does not exist. Okay, so if you see the right hand side, why we can't use the formula to find limit x tends to 1 f of f plus g of x? Because to find the this limit, if you use this formula or using this formula, okay, this is equals to L and this is equals to M. Okay, so I want to use this formula but I can't use. Why? Because what is the value you can take L here? What is the value you can take L here, and what is the value you can take M here in these both values? Because for one single real number you can't take two values, no? A single real number you can't take two values. Then how can you add? So you can't use this formula rule if either of L or M exist, don't exist. Because we want L to be a single unique. We want L to be a unique number, okay, single number. LHL is not equal to RHL, then you can't have a L as the average of that. Okay, so for writing using this rule, it should adjust and it should give some numerical value L, and it should adjust and it should give some numerical L M, and we can add this. If L don't have some certain value, particular value, and M don't have some particular value, then we can't add that. Okay, there should be unique value for L and M to add it. समझ में आ रहा है? Then the question comes how to find when individual limit don't exist. Okay, here we see individual limit didn't exist. So limit x tends to 1. The question is limit x tends to 1 f of x plus g of x. ठीक है, so equals to limit x tends to 1 limit x tends to 1 f of x is step x plus flower part of x. Okay, so here how I will find? Okay, that is the question. See, here what we should do is take left hand. We should assume this whole step x plus flower of x as a new function. Okay, that new function is h of x. H of x equals to step x plus flower of x. Okay, this is a single function. Okay, right from now. Okay, then you should find limit x tends to 1 h of x. Okay, समझ में आ रहा है? We should take step x plus, we should consider step x plus flower part of x as a single function, that is h of x. Okay, then we should find limit has x tends to 1 h of x equals to, then let's find left hand limit of a function. Okay, limit x tends to 1 minus h of x equals to limit h tends to 0 f of 1 minus h, the h of 1 minus h. समझ में आ रहा है? समझ में आ रहा है? Good. This is equals to limit h tends to 0 h of 1 minus h. We consider h as step x plus flower part of x. Okay, so h of 1 minus h is step of 1 minus h plus flower part of 1 minus h. ठीक है, so here, so limit h tends to 0, this is just less than 1. Okay, since h is positive, okay, and infinitely small, so step of 1 minus h must be equal to 0. Okay, so this is equal 0. Similarly, limit h tends to 0, flower of 1 minus h. Okay, this must be h tends to 0, so it must be 1, so the value is 1. ठीक है, समझ में आ रहा? Okay, and similarly if I find right hand limit x tends to 1 plus h of x, and my h of x is limit x tends to 1 plus step x plus flower part of x. ठीक है, good. And it is limit h tends to 0, step of 1 plus h. Okay, and flower part of 1 plus h. Okay, step of 1 plus h is, this is equals to 1 because h is positive and small, and this is equals to h. Since h is small, this tends to 0, so it is tends to 1. समझ में? Good. Understand? So I know you people get confused. So here, if you observe now, limit x tends to 1 minus f of x plus g of x. What we got equals to limit x tends to 1 minus step x plus flower part of x equals to limit x tends to 1 minus, this is we consider as h of x equals to plus 1. ठीक है. Similarly, limit x tends to 1 plus f of x plus g of x equals to limit x tends to 1 plus step x plus flower part of x equals to limit x tends to 1 plus h of x equals to plus 1. समझ में आ रहा है? देखो, means we can say limit x tends to 1, f of x plus g of x equals to 1, exist and equals to 1. Okay, I know you people got confused. Let me explain observation here. What we can infer from here? Here we should observe one thing. Here I said ki though individual limits, okay, limit x tends to a f of x. Okay, so individual limits, limit x tends to a f of x, comma limit x tends to a g of x, don't, either of these limits don't exist, then also limit x tends to a f of x plus g of x may exist. We seen from above formula. Okay, so what is our observation? Individual limits here sometimes it don't exist. Okay, step x, step flower part of x, but if you combine and find limit, then their limit may exist. Okay, so I want to explain in brief what I want to say here. Okay, I want to say here limit x tends to 1, step x plus lower part of x. Okay, here it was here we can't find like this. Okay, limit x tends to 1, lower part of x, and limit x tends to 1. Okay, so this limit exists, this doesn't exist, this doesn't, so we can't use this formula to find this. But how to find then? Because since we can't have a single value for L, and we can't unique value, because this limit does not exist, limit does not exist, means we'll have left hand limit something 0, and right hand limit we got 1, so L can't have unique value because limit does not exist. Similarly here also, limit does not exist, means M don't have single value, so you can't add this both, so you can't use this formula. So how we are getting this adjust? So here what we are doing, if you observe in brief, here what we are doing, here we assumed this as a single function h of x. Okay, here we are finding LHL, right, left hand limit and right hand limit, and we are giving some value. Okay, if let's take example, if limits exist, you are finding limit x tends to a f of x, left hand limit and right hand limit, and you are giving a single value L for that if exist, and you are giving left hand limit and right hand limit you are finding and giving a single value M, and you are adding, then you are adding. Okay, after finding individual limits. But here you assumed it as a single function first, then you are applying. So when you are applying, I am applying limit x tends to 1 minus first to h of x, a single function, then limit x tends to 1 plus and finding h of x. But here what I am doing, here I am applying limit x tends to 1 minus to whole function h of x. But uh, here I am not finding limit x tends to 1 minus to whole function h of two functions at a time. Here I am finding full limit to single function and full limit to single function, and if they adjust, then we'll get some output L and M, then we are adding them. Okay, here x tends to 1 minus, I am finding h of x, and x tends to 1 plus, I am finding h of x, and if these both are equal, then we got the final limit. Understand, we got this as 1 and with this as 1, since these both are equal, we got the final limit. समझ में आ रहा है? Here we are taking x tends to 1 minus and finding full function, but here x tends to 1 individual function we are finding and we are taking out. After finding to full complete function, we are then seeing whether they are equal or not. Okay, so I'm thinking you people understand this. फंक्शन को मर्ज करो, फिर लिमिट, see whether limit exists or not. Okay, next, second part, second rule, limit x tends to a f of x into g of x. Okay, good, equals to limit x tends to a f of x into limit x tends to a g of x. समझ में आ रहा? So multiplication of function. So let's take example. The example is limit x tends to 0 e power x ln of 1 plus x, okay, minus ln of 1 plus x by x square. Okay, this is our example. How to find using this formula. एग्जाम में फॉर्मूला नहीं, यू जस्ट use this as a tool for simplicity. Okay, these are basic questions. Okay, so here we can separate, we can take common ln of 1 plus x. Okay, ln of 1 plus x, ठीक है, into e power x minus 1 by, I want to write x and x like this, x into x equals to x square, ठीक है. Now what is our condition? Our condition is, for using these rules, both limits, limit x tends to a f of x and limit x tends to a g of x must adjust. Okay, I assume f of x as, let f of x equals to ln of 1 plus x by x. Okay, and g of x equals to e power x minus 1 by x. ठीक है, समझ में आ रहा है? So I want this is my g of x and this is my f of x. Now I want to see whether this function exists at x equals 0. So limit x tends to 0, ln of 1 plus x by x. ठीक है, I want to see whether it exists or not. Okay, so left hand limit, take left hand limit, left hand limit is, so ln of 1 plus x expansion क्या बच्चों, ln of 1 plus x equals to x square minus x square by 2 plus x cube by 3. Okay, so on. So we can write as numerator as x minus x square by 2 plus x cube by 3 plus so on, by denominator is x. Okay, so left hand limit is limit x tends to 0 minus this quantity f of x equals to limit h tends to 0 f of 0 minus h. Okay, f of 0 minus h is 0 minus h, ठीक है, minus 0 minus h whole square by 2 plus 0 minus h whole cube by 3 plus so on. Okay, good. So by 0 minus h, ठीक है. So here take common minus h. I can take common minus h from numerator and denominator. Minus h, then numerator will become 1 plus h by 2 minus h square by 3, ठीक है, and so on, and denominator is 1. Okay, so now since h is not exactly 0 but tending to 0, okay, h is not exactly 0 but tending to 0, I already said in the first class. Since h is not exactly 0 and tending to 0, so we can cancel these both. Okay, so now limit x tends to 0, this value, this is limit x tends to 0, this value is 0 and this value is 0, and all values which has power of h will be 0. Okay, so what you will get, we will get is 1 plus 0 plus 0, so it is 1 value 1. Okay, so this is left hand limit, we got value 1. Similarly if you take right hand limit Our right hand limit is limit x tends to 0 plus ln of 1 plus x by x. ठीक है, good. Limit x tends to 0 ln of 1 plus x by x equals to limit h tends to 0 f of x, so ln of 1 plus h by h equals to h minus h square by 2 plus h cube by 3 plus so on by h. Okay, so this is equals to, you again take h common, so h by h, so this is 1 minus h by 2 plus h square by 3 plus so on. Okay, समझ में आ रहा है? So since again h is not exactly 0 but tending to 0. Okay, so since h is not exactly 0 but tending to 0, we can cancel out these both. Okay, good. Again h tends to 0, this, since h tends to 0, this can be, this goes to 0, this goes to 0 and so on, so it is, this value goes to 1. समझ में आ रहा है? So we can conclude, what we can conclude बच्चों, we can conclude limit x tends to 1 minus ln of 0 minus ln of 1 plus x by x equals to limit x tends to 0 plus ln of 1 plus x equals to 1. ठीक है, so this is our limiting value, so we can say limit adjust. Okay, and let's note here L equals to 1. Now take second function g of x. G of x equals to e power x minus 1 by x. Okay, now limit x tends to 0, e power x minus 1 by x equals to expansion of e power x. बच्चों जब बताओ expansion of e power x, e power x equals to 1 plus x square by 2 factorial plus x cube by 3 factorial plus so on. पता है ना expansion, so we can write it as 1 plus x square by 2 factorial plus x cube by 3 factorial plus so on minus, you have one more one here, minus 1 by here again x. Okay, so you can cancel out 1 and 1. Okay, so remaining we have, and let's find left hand limit. Limit x tends to 0 minus e power x minus 1 by x. Okay, so we can write it as limit h tends to 0 e power 0 minus h minus 1 by minus h. Okay, so substitute minus h here equals to, we already find that e power x minus 1, so minus h plus, substitute minus h here, minus h plus minus h whole square by 2 factorial plus minus h whole cube by 3 factorial plus so on by minus h. Okay, take minus h common. If you take minus h common, then numerator left with 1 minus h by 2 plus h square by 3 factorial plus so on. Since h is not exactly 0 but tending to 0, okay, so we can cancel out these both. Since h is tending to 0, h by 2 tends to 0, h square by 3 factorial tends to 0, this value equals to 1. ठीक है, समझ में आ रहा है? Now again right hand limit of this limit x tends to 0 plus e power x minus 1 by x. So it is limit h tends to 0 plus f of 0 plus h, g of a 0 plus h. So equals to, again substitute, we already got, that is 0 plus h plus h square by 2 factorial plus h cube by 3 factorial plus so on minus 1 by, I am writing directly expansion, okay, by plus h, okay. Minus 1 plus 1 cancel. So if you take h common again, h by h 1 plus h by 2 factorial plus h square by 3 factorial, so on, okay. So since again h is not exactly 0 but tending to 0, we can cancel out. So now h tends to 0, this value tends to 0, this value tends to 0, and all tends to 0, so we will get equals to 1. So we got finally what we got, बताओ, left hand limit equals to right hand limit equals to 1, okay, means both so we can say limit x tends to 1 e power x minus 1 x equal adjust, okay, then and that m equals to 1, okay. So let's go to our rule. What we have rule? If both L comma M exist, then we can use this limit x tends to a f of x into g of x equals to limit x tends to a f of x into limit x tends to a g of x. So this is again substitute direct value, means this is L into M. We are going to substitute direct values, okay. So what is the value of M? L equals to 1. 1 into 1 equals to 1. In the left hand we have the question e power x into ln of 1 plus e power x minus 1 by x ln of 1 plus x by x. So we got answer 1, okay, done. So now again same, the thing is कि can we use this same rule if either of L comma L M don't exist, okay, can we use this rule, बताओ बच्चों? Answer is no, we can't use. Why? For using this rule L comma M must exist. I will show with example again. Example, let's take f of x equals to step x, ठीक है, समझ में आ रहा है? g of x equals to 1 by step x, ठीक है. So now my question is limit x tends to 2 f of x into g of x. This is my question. How to solve? Okay, let's solve. Let's see initially. Let's see whether individually limits exist or not. Okay. Let's find individual limits. Limit x tends to limit x tends to 2 step x individual limits. So left hand limit we can take equals to limit x tends to 2 minus step x equals to limit h tends to 0 step of 2 minus h. ठीक है बच्चों बताओ step of 2 minus h कितने since h is positive and 2 minus h is less than 2 but greater than 1 so this value is 1 समझ में आ रहा है good similarly right hand limit is limit x tends to 2 plus step x equals to limit h tends to 0 step of 2 plus h step of 2 plus h when limit h tends to 0 is 2 समझ में आ रहा है good so left hand limit is not equal to right hand limit does not exist okay so we can infer from here means we don't have an unique value of L since we got two values of limiting values from left side we got 1 and from the right side we got 2 so we don't have single value of L okay similarly if you take limit x tends to 2 1 by step x 1 by step x equals to limit right hand limit left hand limit we are taking first left hand limit x tends to 2 minus step of 1 by step x okay this is equals to limit h tends to 0 1 by step of 2 minus h equals to okay good limit h tends to 0 step of 1 by 2 minus h since h is positive 2 minus h is since h is positive 2 minus h is less than 2 okay and h is very small so 2 minus h is greater than 1 so 1 by step of 2 minus h is 1 so it is equals to 1 समझ में similarly right hand limit x tends to 2 plus 1 by step x equals to limit h tends to 0 1 by step of 2 plus h okay since 2 plus h is positive 2 plus h is greater than 2 okay so step of 2 plus h is 2 so it is equals to 1 by 2 so left hand limit not equals to right hand limit so we can say limit does not exist and we don't have then we didn't get an unique value for m Okay, once we got left hand limit is 1 and right hand limit is 1 by 2, so we don't have any unique value, two values, so because limit does not exist. Now what we can say, now the question is, so again limit x tends to why we can't use that formula, limit x tends to a f of x into g of x equals to limit x tends to a f of x into limit x tends to a g of x. Why we can't use? मैंने बताया सेम, here right hand is l into m ना. Okay, ठीक है. Okay, let's write again. Limit x tends to a f of x into limit x tends to a g of x equals to l into m. For writing, for multiplying l into m, you should have a particular real number for n and m. If you don't have a single value, how will you multiply? So we can't use this formula if either l or m don't exist, because we saw limit x tends to a step x didn't exist, limit x tends to a flower of x 1 by step x also didn't exist, so we can't use this formula. Then how you will find? How you will find limit x tends to, limit x tends to f of x into g of x step x into f of x into g of x. We will assume we will take this as a new function, h of x equals to f of x into g of x. Okay, then we will find like this, h of x, okay, equals to, here for h of x, instead of finding individual limits, we are taking the multiplication as h of x single function, and we are finding left hand limit of h of x and right hand limit of h of x, and we are seeing whether they are equal or not. Okay, if they are equal, then limit exists. If not, the limit does not exist. Okay, so limit x tends to 2, h of x is step x into 1 by step x. Don't cancel here, just so just to teach you concept. So here limit x tends to 2 minus, this is same left hand limit, equals to limit h tends to 0 step of 2 minus h by 1 minus 1 by step of 2 minus h. This value is 1 and this value is 1, so answer is 1. So okay, good. Again similarly, right hand limit is limit x tends to 2 step x into 2 plus step x into 1 by step x equals to limit h tends to 0 step x step of 2 plus h by 1 by 2 plus h. This is 2 into 1 by 2, this is equals to 1. Okay, so we got what we got, left hand limit of h of x equals to 1, right hand limit of h of x equals to 1, and we can say limit exists and that value is 1. So this answer is 1. समझ में आ रहा है? We are considering we are not using that formula, but we are considering f of x into g of x as a single h of x, and we are finding limit x tends to a minus h of x and limit x tends to a plus h of x, and we are seeing whether they are equal or not. Okay, but there we are finding individual limits first, and we are getting some l and m values of individual limits, then we are multiplying. Okay, that's the difference. So observation. So here you can observe that what you can observe, though individual limits don't adjust, their multiplication limit extends to a f of x into g of x may adjust. We have seen just one example, but you can't multiply like that. You should take you can't multiply that right hand side. You should take left hand side, extends to a minus and extends to a plus, and you should multiply you inside itself. You should take a new function h of x, and you should do some manipulations and get answer. So yeah, next third rule. Limit x tends to a f of x by g of x equals to limit x tends to a f of x by limit x tends to a g of x equals to L by M. Okay, so yeah, this is the third rule. So if M adjusts to these rules, you can use. If M don't adjust, you can't use this rule, but you should struggle with the individual limit h of x. So let's take example. Example is let f of x equals to minus x power 4 plus 2x square minus 4 g of x equals to x cube minus 2x square minus 3. Okay, so my question is limit x tends to 3 f of x by g of x. Okay, this is my question. Okay, so let's see whether the individual limits adjust or not first to use the formula. Okay, limit x tends to 3 f of x equals to, let's find left hand limit. Left hand limit equals to limit x tends to 3 minus f of x equals to limit h tends to 0 f of 3 minus h equals to minus of 3 minus h whole power 4 plus 2 into 3 minus h whole square minus 4. This is equals to h tends to 0, so this is equals to minus 3 power 4 equals to minus 81. Okay, plus h tends to 0, this is 3 square 9 into 18 minus 4, this is equals to minus 67. Okay, 18 5. Okay, so 14 minus 64. Similarly, limit x tends to 3 f of x equals to right hand limit. We should find right hand limit. Limit x tends to 3 plus f of x equals to limit h tends to 0 minus of 3 plus h whole power 4 plus 2 into 3 plus h whole square minus 4 equals to, this is again h tends to 0, this is minus 81 plus h tends to 0, this is 3 square 9 9 2 the 18 minus 4, this is again minus 67. Okay, then we can say left hand limit equals to right hand limit equals to minus 67, means limit adjust, and we got L equals to minus 67. Okay, similarly, if you take g of x, limit x tends to 3 for g of x equals to limit x tends to 3 minus g of x equals to limit h tends to 0, g of x is 3 minus h whole cube minus 2 into 3 minus h whole square minus 3. This is again 3 square 27, h tends to 0, 3 square 9, 9 2s are 18, minus 3. This is equals to 6. Okay. Similarly, we can find right hand limit. Limit x tends to 3 plus therefore g of x equals to limit h tends to 0, g of x equals to 3 plus h whole square whole cube minus 2 into 3 plus h whole square minus 3. Okay, limit h tends to 0, this is 3 cube 27, 27 minus 3 square 9, 9 2 is 18, 18 minus 3 21, 27 minus 21 6. Left hand limit equals to right hand limit equals to 6, so m equals to 6. समझ में आ गया. So now we can use that formula. We can use that formula. So our question is limit x tends to 3 f of x by g of x, f of x by g of x equals to limit x tends to 3 f of x by limit x tends to 3 g of x equals to limit x tends to 3 f of x minus x power 4 plus 2x square minus 4 by g of x, x cube minus 2x square minus 3. Okay, so this is equals to what we got this value minus 67, this is 6. Okay, good. So this is equals to L by M, this is equals to minus 67 by 6. Okay, now so this is how we use this rule. So again can we use this rule if either of limits don't exist? Let's take example. Limit x f of x equals to cot x. Students, due to some technical issue our last class got discontinued. Okay, so now I'm going to continue the same class, same lecture. So I'm giving the name as lecture, this is part B of lecture 3. Okay, part B. Okay, at last we are talking about this formula, this rule number 3 is the rule next stands to. Okay, limit x tends to a f of x by g of x equals to, ठीक है, limit x tends to a f of x by limit x tends to a g of x, ठीक है. And we discussed one question also, one example. Okay, what is the example we discussed? Some x power 4 minus x square ऐसे कुछ example है, and we got limiting value is minus 67 by 6. Okay, and again the question arises कि whether this rule can we use this rule even when either of limit don't exist? बताओ. The answer is no. समझ में आ रहा है? For using this rule ना, both limit must exist. Both this is equals to L by M. Both left limit x tends to f of x should exist and it should have some value m, l. And similarly, limit x tends to a g of x should exist and it should have some value m. Then only we can use this rule. Okay, let's understand through example. Example is limit x tends to 0. Okay, let's take f of x equals to cot x. Good. And g of x equals to 1 by sin x. f of x equals to cot x and g of x equals to 1 by sin x. Let's see whether individual limits exist or not. Individual limits, let's find for cot x. Limit x tends to, my question is find limit x tends to 0 f of x by g of x. So let's see whether f of x and g of x exist at x equals 0 or not. Okay, limit x tends to 0, f of x equals to, let's find left hand limit first. Left hand limit equals to limit x tends to 0 f of cot x 0 minus cot x. This is equals to limit h tends to 0 cot of 0 minus h. Okay, good. This is equals to cot 0 minus h. बताओ क्या है? H is positive, cot 0 minus h is just less than 0, and it tends to, where it tends to minus infinity. Okay, good. Similarly, right hand limit equals to x tends to 0 plus cot x equals to limit h tends to 0 cot of 0 plus h. Okay, cot of 0 plus h. Since h is positive, cot just greater than 0, cot of just greater than 0 is plus infinity, because cos 0 by sin 0, sin 0 tends to 0 and cos 0 tends to 1, so it is going to plus infinity, so it is plus infinity. Okay, so left hand limit we got minus infinity, right hand limit we got plus infinity, means left hand limit not equals to right hand limit implies, बताओ implies क्या है? Limit does not exist. ठीक है, good. समझ में आ रहा है? So now limit does not exist, then what is the value you will give for L? If limit does not exist, then there is no meaning of L, because L is getting two values. Left hand limit is minus infinity, right hand limit is plus infinity, so no value for L. Similarly, limit x tends to 0 g of x. Let's see whether g of x exists or not. Okay, limit x tends to 0 g of x equals to left hand limit. If you find what is the left hand limit, limit x tends to 0 minus g of x, ठीक है, equals to limit h tends to 0 g of 0 minus h, ठीक है, this is equals to g of x is 1 by sin x, this is 1 by sin 0 minus h, limit h tends to 0, this is sin of 0 minus h is minus 0, and this value tends to minus infinity. ठीक है, good. Similarly, right hand limit is limit x tends to 0 plus, okay, uh, g of x equals to limit h tends to 0, g of 0 plus h, okay, this is equals to limit h tends to 0, 1 by sine of 0 plus h. 1 by sine of 0 plus h is, as h tends to 0, this sine h tends to plus 0, and 1 by sine h tends to plus infinity, okay. Left hand limit we got minus infinity, right hand limit we got plus infinity, and what you can say, अच्छा, left hand limit is not equals to right hand limit, so implies limit does not exist, ठीक है, ठीक है, limit does not exist. Then again here for m you don't have any value to give, because what is the value, what is the meaning of m here? Here if limit x tends to a g of x, if this left hand limit of g of x and right hand limit of g of x exist and they are equal, when they are equal you will get some value of that equality, that value is m. If they are not equal, then how you will give to some value to m, okay, there will be no unique value, you can't give any value, okay. So here also limit don't exist. So I want to say here key when these limits don't exist, you don't have unique value of L and M. So for finding limit x tends to a f of x comma g, f of x by g of x, we can't use the formula limit x tends to a f of x by limit x tends to a g of x if either of L comma M don't exist, okay, समझ में आ रहा है, because we are not getting any particular number for L or M, and how will you use this formula? You can't use. So then how will you solve that? How will you solve that? Okay, good question. The question is how will you solve that? So they asked the question limit x tends to 0 f of x by g of x, ठीक है, this is equals to limit x tends to 0, f of x is cot x by 1 by sin x, ठीक है. Instead of separating this function into f of x and g of x and dividing, okay, instead of separating like this numerator and denominator, you just assume that this is a single function, okay, समझ में आ रहा है, and then apply limit, because limit individual limits doesn't exist here, so you can't separate into individual limits, okay. Whenever individual limits don't exist, you can't separate like this, you should combine this whole function into a single function and you should apply limit, okay. So I assume that h of x equals to cot x by 1 by sin x, okay, this is equals to cos x, समझ में आ रहा है. So here again, so this is equals to, this is h of x, so I assume this as a single function, that is limit x tends to 0 h of x. So now apply limit to h of x, okay, a single limit, no need to divide. So left hand limit equals to limit x tends to 0 minus h of x equals to limit x tends to 0 minus h of x is cos x, equals to limit h tends to 0 cos 0 minus h. This is equals to +1. So you understand? Similarly limit x tends to 0 h of x, right hand limit we want to find. Okay, 0 plus h of x equals to limit x tends to 0 plus cos x equals to +1. Okay, this is left hand limit and this is right hand limit. So you can observe left hand limit equals to right hand limit equals to +1, means the value of limit x tends to 0 f of x by g of x equals to +1. समझ में आ रहा है? What is your observation here? Here your observation should be, see, the first observation is if whenever if the individual limit don't adjust, still the combined limit होता है ना, it may adjust. Okay, if you divide. And the second thing is you can't use this formula. Okay, well, if the individual limits adjust, okay, don't adjust, because you can't give a unique value to L and M. Okay, so you should assume a new function. Here what you are doing, if when you are using this formula, when the limit adjusts now, you are finding a complete limit. Okay, complete limit, and you are getting some value. Left hand limit equals to, here what you are getting, left hand limit of function f of x, and limit of function f of x. Here what you are getting, left hand limit of function f of x equals to L, and right hand limit of function f of x is L. So you are giving the limit, complete limit value is limit of f of x equals to L. Okay, similarly here also left hand limit of g of x equals to M, right hand limit of g of x equals to M, and we are getting limit of g of x equals to M. Okay, and you are dividing these both after finding a complete limit. But here initially when the limit don't adjust now, when the individual limit don't adjust now, then you assume that this is a single function, and initially the single function is h of x, and initially you are taking left hand limit of a whole function f of g of x by h of x. Okay, here what you are doing, here if you observe now, here you are taking a whole function f of x by g of x, and then for the whole function you are finding left hand limit. Here for a single function you are finding both left and right hand limit and getting some value there. Here for whole function you are finding left hand limit and left hand limit of h of x, not a single function. Okay, and right hand limit of h of x, and you are equating whether these is equal or not. Okay, if they are equal, then limit adjust and we are getting some value. Here full limit of individual function. So when limit don't adjust, you should combine the function, then find left hand limit and right hand limit. This is how we will do. So whenever you see question now, always don't use this formula. When the individual limits adjust, then only you can use this formula. If not, you should go in this main way only. Okay, I think you people got it. Next question, next rule. The fourth rule is limit x tends to k into f of x equals to k into limit x tends to f of x समझ में आ रहा है equals to k into l. Here also limit extends to a f of x must adjust here also क्योंकि if it don't adjust ना you can't multiply to a single number k any number k because for multiplying to a particular real number na other number should be other has unique value l. If limit don't adjust you can't give a particular value to this limit. Okay, so that is the thing. The next one, fifth one is limit x tends to a f of x power g of x equals to limit x tends to a f of x power limit x tends to a g of x. समझ में आ रहा है? Good equals to L power m. Okay, let's take an example. Example is let's take f of x equals to sin x by x, g of x equals to cos x. Then my question is find limit x tends to 0 f of x power g of x. Okay, that is my question. Now, so how to solve this? बताओ. Let's see whether if individual limits adjust or not. Okay, if individual limits adjust then we can use this rule. Okay, good. So individual limits, limit x tends to 0 sin x by x. So let's find first left hand limit. What is the expansion for sin x? Sin x equals to x minus x cube by 3 factorial. Okay, plus x power 5 by 5 factorial plus x power minus x power 7 by 7 factorial, so on. You substitute here. This is x minus x cube by 3 factorial plus x power 5 by 5 factorial, so on by x. ठीक है, समझ में आ रहा है? Limit है, then left hand limit is limit x tends to 0 plus left hand limit. This is equals to limit h tends to 0 f of 0 minus h means 0 minus h minus 0 minus h whole cube by 3 factorial plus 0 minus h whole power 5 by 5 factorial and so on by 0 minus h. Okay, good. समझ में आ रहा है? This is equals to minus h कॉमन ले लो. If you take minus h कॉमन ना, then it is equals to 1 minus h cube minus h square by minus h square by 3 factorial plus h power 4 by 5 factorial minus h power 6 by 7 factorial and so on. ठीक है? Since h is not exactly 0 but tending to 0, okay, then you can, because so we can cancel this both. So when h tends to 0, h square tends to 0. When h tends to 0, h 4 tends to 0. When h tends to 0, this tends to 0. So answer is 1. समझ में आ रहा है? Okay. So similarly, this is left hand limit, we got 1. Left hand limit we got 1. Similarly, if you find right hand limit na, right hand limit, okay, that is limit x tends to 0 plus sin x by x. Okay, good. This is equals to limit h tends to 0 sin of 0 plus h by 0 plus h. Again, this is h minus h cube by 3 factorial plus h power 5 by 5 factorial minus h power 7 by 7 factorial and so on by plus h common ले लो 1 minus h square by 3 factorial plus h power 4 by 5 factorial minus h power 6 by 7 factorial and so on. Since h is not exactly 0 but tending to 0. Okay, good. What you can do, बच्चों बताओ? You can cancel this both. So limit h tends to 0, this tends to 0, this tends to 0, this tends to 0. So this value is 1. Okay. So what we got finally? Left hand limit equals to right hand limit equals to 1. So we can say limit x tends to 0 sin x by x equals to 1. Limit adjust and limit value equals 1. Okay, means L value we got 1. So we got L equals to 1. Similarly we can find limit x tends to 0 cos x. Okay, समझ में आ रहा है? Limit x tends to 0 cos x equals to limit x tends to 0 cos x equals to, okay, this is equals to, let's find left hand limit again. Limit x tends to 0 minus cos x equals to limit h tends to 0 cos of 0 minus h. Okay, this is equals to cos of 0 minus h is cos h, as h is this is negative, cos minus h is plus h. Okay, cos plus h. So this is, and cos h tends to 0 cos h is plus 1. Similarly, limit x tends to 0 cos right hand limit x tends to 0 plus cos x equals to limit h tends to 0 cos of 0 plus h equals to limit h tends to 0 cos h is again plus 1. So we can see again here left hand limit equals to right hand limit equals to plus 1. So limit adjust, and so we got limit x tends to a cos x equals to cos x equals to 1. So we got m equals to plus 1. Okay, good. समझ में आ रहा है? Observe. Now, so we found that both limits individually adjust, and we got L equals to 1 and M equals to 1. Since both limits individually adjust and we got L equals to 1 and M equals to 1, so we can find directly limit x tends to 0 f of x for g of x, limit x tends to 0 sin x by x power cos x equals to 1 power 1 equals to 1. Okay, ठीक है, चलो. And similarly, if they don't adjust, we can't use this one if the individual limit don't adjust. Okay, let's move forward. Sixth one is limit x tends to a f of g of x. ठीक है, limit x tends to a f of g of x function in a functional formula equals to f of limit x tends to a g of x. Okay, this rule particularly used for following times. Okay, following types of questions. First one is limit x tends to, and there is note point here key f should be continuous. F should be continuous at g of this is equals to f of m. Okay, so f should be f should be continuous at g of x equals to m. Okay, this is the condition. Okay, and limit should exist also. Okay, and this is used at times limit x tends to a. When they given question key log of f of x, then we can write this as log of limit x tends to a. We can take log x outside, log term outside, and this is equals to log of limit x tends to f of x. Okay, the second thing is limit x tends to a e power f of x. Okay, this we can write when the questions are like this. You can use this limit x tends to a f of x. If limit x tends to f of x exists, then only you can use this rule. Similarly, limit x tends to a mod of f of x equals to mod of limit x tends to a f of x. समझ पा रहे? These are the three particularly we use this formula, this one, and here also the individual limit. Sorry, it is g of x here. Sorry, here also the individual limit must exist. Okay, next so let's solve some questions. Let's solve some questions. Okay, the first question is if limit x tends to a f of x plus g of x equals to 2, limit x tends to a f of x minus g of x equals to 1, then find limit x tends to a f of x into g of x. Okay, this is our question. Okay, now how will you find? My approach is I will take this as a I will assume f of x x plus g of x is equals to some new function a of x. Okay, and f of x minus g of x equals to some b of x. I assume like this. So now what I have this now means if the whole limit extends to a f of x plus g of x equals to 2, it means they are giving indirectly limit extends to a of x equals to 2. Similarly, limit extends to a f of x minus g of x equals to 1. It means the whole limit extends to a b of x equals to 1. Okay, so what we can do here, we can say, so individual limit edges, then we can, I want to find limit extends to a of x plus b of x, okay, equals to, since individual limits exist, so we can write it as using first rule, limit extends to a of x plus limit extends to a b of x. Okay, good. So this is equals to some l plus m. Okay, so here it is equals to l plus m. So what is the value of this? A equals to this and b equals to this. So it is equals to limit extends to a plus b is 2 f of x equals to l plus m. L plus m is 2 plus 1 equals to 3. So we can write like here equals to limit extends to a f of x equals to 3 by 2. Good. समझ में आ रहा है? So this is our value. Similarly I can separate a minus b. Limit extends to a minus b of x equals to limit extends to a of x minus b of x. Limit extends to, this is a of x minus, since individual limits exist, extends to a b of x. What is a of x? This is 2, this is 1, l minus m, this is plus 1. Directly we can separate, and left hand we can get is a minus b is limit extends to a 2 into g of x. So implies limit extends to a g of x equals to 1 by 2. समझ में आ रहा है? We got the f of x and g of x. Now what we got limit extends to a f of x equals to 3 by 2. Limit extends to a g of x equals to 1 by 2. It means individual limit exists and we got some values of individual limits are 3 by 2, 1 by 2. Again I want to use now third rule. Okay, what is the third rule? Second rule. What is the second rule? Limit extends to a f of x into g of x equals to limit extends to a f of x into limit extends to a g of x. Okay, good. So when we can use this rule, if individual limits exist, okay, equals to l into m. Individual limit exist and we have that value 3 by 2. Individual limit exist and we have that value 1 by 2. So we can write it as 3 by 2 into 1 by 2 equals to 3 by 4. समझ में आ रहा? Okay. So चलो this is our first question. Let's go to second question. Question. Question is limit x tends to 0, x plus 4 by 2 minus x whole power x square plus 2x minus 3 by x minus 1. Okay. So here next. So here which rule I should use? F of x for g of x. For using that rule, I should say whether individual limits exist or not. So this is f of x in my assumption, and this is g of x. So let me see whether individual limit exists or not at x equals 0. Limit x tends to 0, f of x equals to x plus 4 by 2 minus x. Okay. Left hand limit, let's find left hand limit equals to limit x tends to 0 minus x plus 4 by 2 minus x equals to limit h tends to 0, 0 minus h plus 4 by 2 minus 0 minus h. Limit h tends to 0, this is 4 by 2 equals to 2 plus 2. Similarly, right hand limit equals to limit x tends to 0 plus x plus 4 by 2 minus x. This is equals to limit h tends to 0, 0 plus h by plus 4 by, this is again equals to limit h tends to 0, this is equals to 4 by 2 equals to plus 2. Okay, so we got limit equals to limit x tends to f of x 0, f of x equals to 2, means L value equals to 2. Similarly, g of x, limit x tends to 0, g of x is x square plus 2x minus 3 by x minus 1 equals to limit x tends to 0 minus g of x. Okay, limit h tends to 0, this is 0 minus h whole square plus 2 into 0 minus h minus 3 by 0 minus h minus 1. This is 0, 0, 0, minus 3 by minus 1 is plus 3. Okay. Similarly, limit x tends to 0 plus right hand limit is limit h tends to 0. This is 0 plus h whole square plus 2 into 0 plus h minus 3 by 0 plus h minus 1. This is again minus 3 by minus 1 is plus 3. So we got left hand limit equals to right hand limit equals to 3, means limit exists, and we got 3. Okay, m equals 3. Okay, now so we got what we got, limit x tends to 0, x plus 4 by 2 minus x equals to m equals to 2, L equals to 2. Similarly, limit x tends to 0, x square plus 2x minus 3 by x minus 1 equals to m equals to 3. Okay, so now if you use rule, third rule, what is the third rule? Limit x tends to a, f of x power g of x equals to limit x tends to a, f of x power limit x tends to a, g of x equals to L power m equals to 2q equals to 8. समझ आ रहा है? Good. Let's proceed to next question. Next question is if a1 equals to 1, ठीक है, and an plus 1 equals to 4 plus 3an by 3 plus 2an. n greater than or equals to 1, and if limit n tends to infinity, limit n tends to infinity an equals to a, ठीक है, then find the value of j. Okay, now how you will proceed? So solution, I want to apply limit on both sides. We can apply limit n tends to infinity an plus 1 equals to limit n tends to infinity, ठीक है, 4 plus 3an by 3 plus 2an. Okay, good. Let's assume this only. Let's take this. Okay, now can we write this as equals to limit n tends to infinity 4 plus 3a by limit n tends to infinity 3 plus 2a. Can we write like this? What is the condition for writing like this? If you want to write, if you want to find this and using, if you want to use this formula rule, or that the numerator individually, limit of numerator should exist and limit of denominator should exist individually. Okay, and it should give some values element, then only you can use this formula, then you can use. Let's see whether individually exist or not. Okay, so individually limit n tends to infinity 4 plus 3n should exist. Okay, this should exist. For this to exist, if it exists, then we can use this. For it, let's see this is exist or not. Can we write this as like this? If for writing this as like this, these two individual again should exist. Okay, using first rule again. This is rule number 3. This is rule number 1. So we know this exists and this it gives value 4, and this exists and this gives value limit x tends to 3. Limit x n tends to infinity an is they given a. So they got individual exist. Okay, so we can say this also individual exist, and value is limit n tends to infinity 4 plus 3an equals to 4 plus 3a. Okay, similarly, what is the similarly let's see this denominator individually exist or not. For this denominator individually exist, let's see, let's use the formula. Okay, first rule number 1. If these two exist individually, then we can this also exist individually. Okay, so limit n tends to infinity, we know this as 3, and this limit n tends to infinity 2an they given a, so this is 3 plus 2a, means we got some value right hand side, so this must exist. So we got some values, so numerator and denominator we seen their individual exist and their values are L equals to 4 plus 3a, m equals to 3 plus 2a, and we can divide that both as limit n tends to infinity 4 plus 3an equals to by 3 plus 2an equals to 4 plus 3a by 3 plus 2a. ठीक है, And what is the value left hand side of this is limit n tends to infinity an plus 1. Then this is equals to limit n tends to infinity an plus 1. ठीक है. As n goes to infinity, an must be equals to an plus 1, because we don't know what happens at infinity. There is no difference between n equals to infinity and n equals to infinity plus n plus 1 equals to infinity plus 1, because it is very large. So limit n tends to infinity an plus 1 we can write as limit n tends to infinity an. Okay, and this value we got, they given as a. Okay, so we can write it as a. So cross multiply, then you will get 3a plus 2a square equals to 4 plus 3a. Hence a equals to a square, 3a cancel, a equals to plus or minus root 2. Okay, since n is greater than 1, okay, n is greater than or equals to 1, if then they given a1, if you see a2 is 4 into 3a1 by 3 into 2a1. This is 4 plus 3 7 by 5. Again, if you for a3 3a2 by 2 3 plus 2a2. Again, if you substitute 7 by 5, if you substitute and go on like this, now you never get an as negative value. Okay, an is always positive for n greater than 1. So here negative quantity you should not get, so your value is only plus root 2. Okay, so next let's go further. Okay, some important concepts. These are already discussed, but we are discussing again particularly. Okay, if limit x tends to a, f of x into g of x adjust. If the limit x tends to f of x into g of x adjust, then we'll have this adjust in the following cases. We'll have 3 cases. Okay, the first case is limit x tends to a, f of x comma limit x tends to a, g of x, both adjust. Okay, the example we given is f of x equals to e power x minus 1 by x, and g of x equals to, we already given, ln of 1 plus x by x. Okay, good. Similarly, one adjust and one limit x tends to a, f of x adjust, but limit x tends to a, g of x don't adjust. ठीक है. The example is f of x equals to limit x tends to 2. ठीक है, f of x equals to x square minus 4, g of x equals to 1 by x square plus x square minus 6. So limit x tends to 2, f of x adjust, but limit x tends to 2, g of x don't adjust, if you see. Okay, but limit x tends to 2, f of x into g of x adjust. If you multiply, then their multiplication adjust again. don't adjust, but g of x don't adjust, and their multiplication adjust. Okay, this is case 2. Again, the case 3. The case 3 is case 3. Limit x tends to a f of x don't adjust and adjust. Again, limit x tends to a g of x doesn't adjust, but limit x tends to a f of x into g of x adjust. Okay, example we given as limit x tends to 2 step x as f of x, limit x tends to 2 1 by step x in the first class, part 1 part A. This g of x, individual limits they don't adjust, but their multiplication adjust. Okay, these are the 3 cases possible for multiplication to adjust. Okay, similarly, second concept is if limit x tends to a f of x plus g of x adjust, then we will have 2 cases. Case 1, both f of x comma g of x adjust, or both f of x comma g of x adjust. Okay, what does it mean? It means that, okay, the case 2 is both f of x comma g of x adjust, but we don't have the case which one f of x adjust and g of x don't adjust, or g of x adjust and f of x don't adjust. Why? The question comes, why? Either both should adjust or both should not adjust. Okay, then we will have the case k limit x tends to f of x plus g of x adjust, but there is no case of a one adjust and one don't adjust. The question is why. Let's see. Let us take one function g of f of x adjust. Okay, let's take one function adjust, then let's see whether g of x adjusts or not. We can write g of x as f of x plus g of x minus f of x. Can we write like this? Okay, समझ में आ रहा है? Now I want to find limit x tends to a g of x. Limit x tends to a g of x. This is equals to, this we can write as limit x tends to a f of x plus g of x minus, okay, limit x tends to a f of x. Okay, can I write like this? नहीं, sorry, here minus, no, f of x. Can I write like this? Yes, I can write. Again, now this, since we know that they said that limit x tends to f of x plus g of x adjust, and we assume that f of x adjust individually. Since these both adjust individually, we can write it as, from rule number 1, we can write it as limit x tends to a f of x plus g of x minus limit x tends to a f of x. Can we write like this from rule number 1? Yes. Okay, so So since these both adjust individually, this is L, this is M, then we can say left hand side limit x tends to a g of x equals to L minus 1, means limit x tends to a g of x must adjust. Okay, this is a proof. Means if f plus x g of f of plus x, x plus g of x adjust and f of x adjust, then only one function adjusts, then the second function must adjust. This is a proof. Okay, so chalo.